Assalamualaikum and hi, my name is Muhammad Nabil Izham bin NORBI. My ID number is 2023454348. I am from Group 4 from AS1201J.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Hazim bin ROMLEE and my matric number is 2023210104 and I'm from Group 4 from AS1201J.
Hi, Assalamualaikum. My name is AHMAD SYIRAAZI bin Muhammad BASRI. My ID number is 2023848834. I am from Group 4 from AS1201J.
Hi, Assalamualaikum. My name is TUAN ASHRAF bin TUAN ZAINAL ARIFFIN. My ID number is 2023492774 and I'm from Group 4 from AS1201J.
Our objective for this experiment is to determine the volume and density of ball bearing and to determine the volume and density of glass block.
Micrometer screw gauge is used to measure smaller length or distance. A micrometer screw gauge has two scales, which is the main scale and the vernier scale. The main scale of a micrometer is calibrated in millimeter. The calibration of the main scale of micrometer screw gauge vary depending on the range of measurement that the micrometer screw gauge are meant to measure. The vernier scale has 50 equal divisions. Each division is obtained by dividing 5 by 10. The vernier scale moves a distance of 0.5 mm along the main scale when it makes one revolution by turning round once. One division on the vernier scale equal to 0.5 per 50, which equal to 0.01 mm on the main scale. The accuracy of a micrometer screw gauge is 0.01 mm or 0.001 cm. This means that the smallest distance that a micrometer screw gauge can measure is 0.01 mm or 0.001 cm. Accuracy of an instrument is the smallest distance or value of a particular quantity that the instrument can measure correctly.
The vernier caliper is a precision measuring instrument used to determine the dimension of object with high accuracy. It comprises a main scale and a sliding vernier scale, providing measurement to a finer resolution than the main scale alone. This tool can measure external dimension using the main jaws, internal dimension using the smaller jaws at the top, and depth using the stem. To measure external dimension, the object is placed between the jaws, which are carefully closed until they securely grip the object. The screw clamp is tightened to maintain the position during measurement, preventing inadvertent shift. Reading the scale involve noting the first significant figures to the left of the zero on the vernier scale, with the remaining digits derived from the vernier scale division aligned with any main scale division. For optimal precision, multiple measurements are recommended and the arithmetic mean is calculated to minimize error caused by irregularities or deformations in the object due to pressure. It's crucial not to assume a measurement's accuracy is equal to the caliper sensitivity, and a more realistic estimation of the measurement error is obtained by considering the range between the minimum and maximum measured values. This approach ensures a more reliable representation of the object's dimensions.
The apparatus that were used in this experiment is vernier caliper, micrometer screw gauge, weighing scale, ball bearing, and glass block. Figure 2.1 shows the vernier caliper, and figure 2.2 shows micrometer screw gauge.
Procedure for A. Micrometer screw gauge. First, determine the zero error. Second, measure the diameter of the ball bearing. Turn the ratchet knob until a click sound is heard. Third, repeat step 2 at least 3 times at different position of the ball bearing. 4. Record all your data in a suitable table. 5. Calculate the actual diameter reading taking into consideration of the zero error obtained earlier. 6. Determine the weight of the ball bearing. And 7. Calculate the density of the ball bearing.
Procedure for B. Vernier caliper. First, count the whole number of small divisions on the fixed part of the caliper that are to the left of the zero mark on the vernier. This gives you the size of the object to the nearest number of whole millimeter. 2. Find the first mark on the vernier that line up with one of the marks on the fixed part of the caliper. The value of the mark on the vernier then tells you how many fractions of a millimeter are needed to complete the estimate of the size of the object. 3. Determine the zero error of the vernier caliper. 4. Measure the length, width and thickness of the glass block by using the vernier caliper. 5. Repeat step 2 at least 3 times at different positions of the glass block. 6. Record all your data in a suitable table. 7. Calculate the actual measurement by taking into consideration the zero error obtained earlier. 8. Determine the weight of the glass block. 9. Calculate the density of the glass block.
Results. Number 1. To measure the diameter of the ball bearing using a micrometer screw gauge and to determine its volume. V equals to 4/3 pi r cube. Zero error equals to negative 0.01 mm. For the observed reading, diameter of ball bearing millimeter in first attempt is 8.36, second attempt 8.38, third attempt 8.37, and the average is 8.37. As for radius of ball bearing in millimeter, for the first attempt 4.18, second attempt 4.19, third attempt 4.19, and the average is also 4.19. Then move to true reading. The diameter of ball bearing mm for the first attempt is 8.37, second attempt 8.39, third attempt 8.38, and the average is 8.38. As for radius of ball bearing millimeter, first attempt is 4.19, second attempt 4.2, third attempt 4.19, and the average is 4.19.
Second is to measure the length, width and the height of the glass block using a vernier caliper and to determine its volume. The question for it is V equals to length times width times height. Zero error is 0. For the observed reading, length first attempt is 10.7 and for the second attempt is also 10.7 and third attempt also is 10.7 and for the average 10.7. And for the width, first attempt 5.9, second attempt 5.9, third attempt 6.72, for the average is 6.17, and for the height is first attempt 1.82, second attempt is 2.7, third attempt is 1.80, average is 2.1. True reading. For the length, first attempt is 10.7, second attempt is 10.7, third attempt also is 10.7, and for the average is 10.7. For width, first attempt is 5.9, second attempt 5.9, third attempt is 6.72, and average is 6.17, and for the height is first attempt 1.82, second attempt is 2.7, third attempt is 1.8, and average is 2.1.
Analysis. Give all the answers in SI unit. Number 1. Calculate the volume and uncertainties of the ball bearing and the glass block. For ball bearings volume and uncertainty, the volume is 3.08 times 10 to the power of negative 7 meter cube. Delta V, 3 times 10 to the power of negative 9 meter cube. For glass blocks volume and uncertainty, the volume is 1.09 times 10 to the power of negative 4 meter cube. Delta V is 1 times 10 to the power of negative 6 meter cube.
To calculate the density P and the uncertainties delta P of the ball bearing and the glass block. For the ball bearing, the bearing density and uncertainty, the density is 6,812.65 kilogram meter cube, and for the delta P, 325 kilogram meter cube. And for the glass block density and uncertainty, the density is 2,589.91 kilogram meter cube, and the delta P is 0.328 kilogram meter cube.
Discussion. This experiment objective is to find the volume of ball bearing and the glass block using specific physical instruments, which is vernier caliper and micrometer screw gauge. We must simply make sure that we are using suitable instruments to measure the diameter of the items. For example, we use micrometer screw gauge to measure the diameter of ball bearing, while to measure the length, width and height for glass block, we use different vernier caliper. Next, in order to calculate the density for each item, we use weighing balance to determine the mass of ball bearing and glass block. To get even accurate results, we determine if there's any zero error in each items. For micrometer screw gauge, the zero error is negative 0.01 mm. So, all of our observed reading must be minus by 0.01 mm in order to get true reading. As for vernier calipers, we didn't have zero error for the instrument, so our observed reading is equal to our true reading. In order to get accurate results and reducing the errors, before measuring the diameter of the ball bearing, we must turn the ratchet knob until the click sound is heard. Next, we must count the whole number of small divisions on the fixed part of the vernier calipers.
Conclusion. In employing both the vernier caliper and micrometer screw gauge for the measurements, it's evident that each tool contributed to the overall accuracy of the experiment. The vernier caliper provided versatile measurements for larger dimensions, while the micrometer screw gauge demonstrated superior precision in measuring smaller dimensions. The combination of these tools ensure a comprehensive and reliable set of measurements, highlighting the importance of selecting the appropriate instrument based on the scale of the object being measured.